to the next slide. So I like to start with a quote from a very famous Industry 4.0 driver, actually, which is the former CEO of Siemens. And he said in Davos in 2018 at the World Economic Forum, the fourth industry revolution is not just about technology or business, it's about society. So this is not a technology topic per se. This is not a business topic per se. It is a topic around society as well. And how this been put together, this is really the content of the next 30, 45 minutes that we're going to share together here. So who are we? The great looking individual on the top left, that's me. I work for IBM in Germany on the technology side, and I hand over also to my colleague Dilek, who's in the call. Dilek, hello.
Hello, my name is Dilek Seskin. I'm the technical leader for data in AI within IBM. And the best wishes from Mannheim, also 26 degrees.
Great, thanks you. And last but not least, Danny, are you in there also?
Yes, thank you, Thorsten. Hello, my name is Denny Punus. I am based in Abu Dhabi. I am responsible for the region Gulf and Levant for what we have in IBM Global University Program. We are under corporate citizenship and responsibility. So we bring IBM software, resources and tools, some of that will be covered today. So that components for the academia is provided through the Global University Program. So most of the IBM software, tool and courseware that you can integrate in your curriculum is available through the Global University Program for every faculty and every student. Thank you.
Great, thanks, Danny. So let's kick things off. So I'd like to start with a question to the audience, and please use the chat function here within Zoom. And while we see on the right-hand side a video of an assembly process of an IBM Z computer, the question is, please name a product where you have seen the physical manufacturing at a plant. So I'd like to a little bit understand who of you guys have seen already a plant process, either maybe not on video, but really physically. So if you could use the chat real quick and let me know what physical manufacturing process in terms of a product you have seen, that gives us a little bit understanding in terms of where we are. Pressure sensor assembly, Basim, interesting. Seems to be very specific. And a couple more. So it's a very mixed audience here, of course, and we need to coordinate that accordingly, of course. So few have seen that. For a few of you, that's maybe a new thing. Really doesn't matter. We have material for both sides. So if we now move forward in terms of how this looks like, if you look at a sample production line, right, and in average, we can see this here from bottom to top. An average production line has about 2,000 pieces of equipment. It has anything around 200, 300 sensors, and it produces 2,200 terabytes of data a month. Huge numbers. But the situation really is that manufacturing lines are, as you see here, data rich, but getting information is getting the first challenge out of this data, and even driving insights out of that is then the holy grail. So this is where manufacturing really has the challenge in terms of how to drive value out of data. And if you look on a typical situation, only 20% of manufacturers use data analytics as of today. That might sound surprisingly to you. And again, all this data is coming from the IBM Institute of Business Value. You have a link in there. All this material is going to be made available later on. So you see what is the big gap there between what is feasible to do in terms of data availability and what has been done with the data. Two different big things. So if you now go back to your chat box again here within Zoom, and give me your best judgment, just a number. What percentage of manufacturing data remains unused? What do you think? Just give me a number. Use your chat function and let me see what you think are the numbers. So 50, 95, 80, 90. Hey guys, you're not too bad actually. 12. Well, Basim, 12. So the answer really is, I need to jump back here, 90. What a number. 90% of the data being produced in a plant is not used as of today. So this is, of course, the gold mine there in terms of making something useful with this data, which is not used today. It's not because it's been thrown away, but it's because it's irrelevant. It is there, and it is there to be used to do something valuable with it. So the next question then is, what is the average downtime cost of an average manufacturing enterprise in a minute, in a dollar? So how much does it cost to have a manufacturing line, an average manufacturing line, being off for 1 minute? Again, go to your chat window and I'll try to see whether I can see here. So 5,000, Mahat. Okay, 1 million. That's a big difference. And probably anything in between, I guess. 500,000, 2,000. Okay, guys, the answer is 21. 21,000 US dollars a minute cost to have a stoppage at an average manufacturing line. So this is how big the opportunity is. So take that into consideration in terms of where to drive value in a manufacturing process. So if you look on the technologies which are available these days in order to improve manufacturing processes, if you like so, and you see here the outcome of a survey we just recently did on over 1,000 manufacturing leaders in the world. The single number one leading technology driving manufacturing excellence is artificial intelligence, AI. Shouldn't be a surprise. You see a couple of other technologies which are somewhat connected also to AI if you talk on cloud or IoT and analytics. But at the end of the day, AI is really the combining factor in all these. And unfortunately, yes, it is not being implemented at scale. So you see here again the big opportunity which is out on this particular topic. And this applies also in different footprints in terms of the geographies, of course. This is not something where Germany is extremely well positioned and low-cost country like China is worse. No, it's actually vice versa. So you see the opportunity is really across the entire planet on these kind of topics these days. So you might wonder, and what the hell is IBM doing on this? And why is this IBM dude from Germany talking on this? Well, actually, you need to understand very high level, what is the IBM play in the marketplace overall? And this is now the IBM company on one page. And we are a hybrid cloud and AI company. This is how we consider ourselves. So you see here the 4 different layers. You start on the bottom layer, which is infrastructure, where you see like the typical hardware product that we still do. We run a big IBM cloud, of course. We have IBM Z. That is the big machines where 10 out of 10 banks are running IBM Z, 10 out of 10 airlines running this kind of infrastructure. And then you see, of course, public clouds, and also Edge is technology on the lower level. All this is then being combined in a hybrid cloud platform based on Red Hat. That has been an acquisition that IBM has done 2 years ago. And this is the single point of platform that we are running all our business on in terms of hybrid cloud environment. And then on the top of that, you see IBM software and cloud packs. This is where AI software sits. So next to AI and data, we do a lot of stuff on security and automation, of course, on the software side. And we have a big consulting unit you see on the very top. And then on the right-hand side, we work with a lot of partners on the software side and also on the system integration side. However, if you now look what that means in terms of the Industry 4.0 context, you see here the different major domains that we are walking in regards to Industry 4.0. So on the one side, we have a lot of partners which combine our solution towards the end clients, like the ABBs, the Siemens, the Samsung. We all work with them on a partner side, but also they are clients of us, of course. And in terms of topics, you see on the right-hand side, plant application modernization, a big, big topic. A lot of plants are out there 30, 40 years, and there's still plants even in Germany running Windows 95. Surprise, surprise. But this is really the reality here and there. You see other topics, OT security. OT stands for operations technology security. So this is not IT security in terms of your laptop. This is security in terms of hacking machines on the shop floor. A big topic, a big issue, and a lot of efforts are being done over there. Other topic includes, of course, in terms of production, 5G. So what is the data transmission opportunity that 5G brings to plants? And then last but not least, of course, edge analytics. Not everything what you do in analytics can be done in the cloud, depending on connection capability and connection time. So analytics at the edge means at a physical machine is an important topic. And again, you see all this is then being combined via Red Hat on our platform. So much on the commercial side of things here. The question really is, where is this Industry 4.0 thing coming from? And again, that's probably the reason why we have been invited as being the Germans. It was originated in Germany. And if you look how the evolution really is and where this term really comes from, the terms really started on the right-hand side. So Industry 4.0 has been really defined as cyber-physical models and digital integration across the value chain. And somebody came up with this term Industry 4.0. And then you see the backlight in terms of why 4, because you had 3 major industry revolutions before. It started all in the late 17 in terms of where equipment has been driven with water and steam engines, for example. Then in the late 1870, 1890, Henry Ford started with his mass production of cars, for example. So this was the first time where electrical energy heavily has been used and really drove the second revolution of manufacturing. And then last but not least, in the 70s, 80s, we started the entire automation journey on manufacturing, where more and more robots have been used to automate the manufacturing line. So this is how this term Industry 4.0 really came into place in the first time. And you see here, it started all in 2011. And you see here a picture from the Hanover Fair. This is the biggest dance on industrial manufacturing in the world once a year. Well, actually not the last 2 years because of COVID. And this is where this term really started to be used. And if you see here, what happened then, just 2 years later, a so-called platform Industry 4.0 has been founded. And again, government played a very, very important role. You see here our former Chancellor, Angela Merkel. She really drove this particular initiative. And the reason why we have done that, it was also about driving competitiveness of Germany as a manufacturing site. High labor cost, high quality, but high cost, of course. So Industry 4.0 digitization has been really used to drive down costs, to drive excellence in manufacturing, to protect the status quo that Germany is still a positive and a good place to manufacture, to produce, say, cars. Because otherwise we would lose this position if we are not better and organized than other areas in the world. So it has to have this competitive component in there. And then a couple of years later, working with Industry 4.0 with a lot of proof of concepts and so on and so forth, a new organization has been built, which is called Gaia-X. From 2019, where Europe kind of started this initiative, and it was about digital sovereignty. So it was also the challenge in terms of how do I secure my data in a manufacturing context. And it has been a pan-European initiative, and France and Germany are in the lead on Gaia-X. And then next to Gaia-X, 2 years later, just last year, Catena-X has been formed, which is kind of a derivative from Gaia-X, specific towards the automotive industry, not only the manufacturers, but also suppliers. And of course, we as IBM are very active in these kind of things. So this is where you see how government, the German government, pushed this overall topic from Industry 4.0 to platform industry to Gaia-X to Catena-X. This is the evolution there. So much on theory. And again, you wonder, show me some reality there. And for us, it's always easy to talk also on AI, where we use AI within IBM. So we use our own tools, in particular in our software in terms of automation and so on and so forth. But we also use these kind of capabilities, AI, in our own manufacturing unit. And I give you a little glance right now how this looks like. So if you look in terms of what is our manufacturing portfolio, what are we still selling? So this is the stuff on the lower left-hand side of the blue and red chart I just showed. So we have typical software around tape library, storage, power, and set. So all looks like big black boxes, but actually they are fundamental differences in those kind of boxes. But nevertheless, so this is still an $8 billion US business for us, which is very complex. And I have now a colleague of mine who explaining to you how we are running this for IBM manufacturing. So I'll just start the video here. Hope that works. Okay, I hear there's no sound. Too bad. So let me then do some voiceover on this to make that work for you. So this guy is managing the supply chain for an IBM power system. And you see here how he works with Watson on his computer, where Watson is really acting as an expert in terms of data availability. So you do not need to drill into SAP systems and do complex queries. You can see here, he's just putting questions in terms of what he's working on right now. So what are the firm power orders? So what are the orders which are already in place? So no querying in SAP systems, but the system is really now an expert and driving these kind of things. So Watson have access to all those data sources, and you have then here voice to text, text to speech to text, text to speech kind of capabilities. And Watson as an expert helps you to do your job. So this is one of the biggest deployments that we do in this particular field. So given the fact that this is now not working in terms of the tone, let me stop this and go to the next one. And then typically the question comes, what is this Watson thing all about? So I don't now raise the question in terms of who can explain Watson from you guys. I just put some very basic topics together in terms of what is Watson, right? On the one side, it's a marketing label for our AI tools, if you like so. But actually, it's an entire portfolio of business-ready tools, applications, and solutions. Available on the cloud, but also available on-prem. And the purpose of this is to reduce cost and optimize outcome, not a surprise. And it's very, very easy to consume. In particular, all the cloud options, you can have access to that very easily. So this is based on the IBM Cloud platform, available for everybody, students also. There's a clipping level in there where you don't have to pay. So all students can play with that, and there even universities partner with us in order to deploy this kind of technologies in university programs. And last but not least, responsibility of AI. This is very important to us as IBM. The use of AI can be misused, and we've seen all these kind of fake news kind of environments. So one of our DNA in there is, in particular, make the AI use in a very responsible way. And the way we structured this product really drives the responsibility of AI taking here. Very important to us. So this is the internal story. But you might wonder, yeah, that's great, nice, but what's happening outside? So I have now a couple of examples for you in terms of where AI is being used outside of IBM manufacturing in real manufacturing environments. So the first one is in manufacturing plants, the typical business problem, energy efficiency. And in days of the Ukraine war, shortage of gas, maybe not a big topic in Dubai, but for us here in Europe, it's a huge topic right now. The proper use of energy in plants is a very, very important element. And the use case or the huge project that we have done here is for a cement company. They have around 130, 140 plants, and all these plants are very similar in outcome, but they use all very different level of energy. And the reason for this is they are being managed in a different ways by different people. So what we put here together is a so-called a cognitive plant advisor. So we combined all the data from all the plants and looked what is the optimal way to run those plants in terms of energy efficiency. And then Watson gives an advice to the plant operator, what is the perfect way of running your plant in terms of product outcome quality, but also used energy in there. And you see here on the lower side, the chart box where the sweet spot of the running parameters are of this particular plant. And it's an optimization between energy used and the quality of the cement outcome. So this has been used now in 130 different plants for this particular client. And again, it's not replacing a human being. It is about augmenting decisions from the plant operator. You still need to have this background from the plant operator, but with this insights, this plant operator gets augmentation on this kind of data to optimize his environment.
And
Sir, which age?
There's a question in the chat. Which age group is this? On what you are talking?
Which age group? Well, it's a cement company which is already 30, 40, 50 years old, right? So this is not about an age or how sophisticated the company is. It's about the business problem. Or you mean maybe you had a different question. You say, no, sir. Maybe you can rephrase your question. I probably haven't understood that about the meeting. Okay, I don't understand this comment, Hannah, I have to say.
Hannah, are you there?
Let me then continue. I hope our colleagues in the back can cover this. Okay, good. So business problem number 2, quality management of welding process. Again, I'm coming here from Germany. Automotive manufacturing is a big topic, of course. We see very, very often still challenges in terms of product recalls of cars because of very different reasons. We see this, but also on problems on the welding process. And you just see here a couple of examples just from recent where we had recalls on cars where the welding process hasn't been done very well. So what you could do with Watson is a quality control process for the welding process with acoustic inspection. You might wonder, what the hell acoustic? Well, you usually start with visual. There's no doubt about it. But complementing structured data and unstructured data, and unstructured data is like pictures, videos, and noise. Combining this gives an extra layer of excellence in terms of improving this kind of process. And apparently, the welding process, it generates very different noises or acoustics, depending on the gas that you have in your equipment. So you see here different welding outcomes in here. On the top one, this is how a good weld looks like, and the other one on the bottom look not very nice, and there are different reasons for that. Gas is gone, the gas is too little, too much whatsoever. But the noise that the welding process makes, you can characterize whether this welding process is okay or not. So Watson really has ears. It recognizes or it records the noise done in the welding process and matches this data then with sample data, which then says, hey, this is a good noise, this is a bad noise. And by doing that, you can dramatically improve the welding process quality. You see here greater than 97%. This is a project that we have done with Yaskawa, one of the big global robot manufacturers, been deployed in various big automotive plants, for example. So this is the example on welding with Watson ears, as I used to call that. So another project which I thought is interesting to share with you is something that we do on visual inspection for quality management. This is a project that we have done with Boston Dynamics. Boston Dynamics is one of the big US new edge kind of robots manufacturers. They don't do regular robots, they do smart robots. And those robots have a brain, have kind of ears, they have a nervous system. And you see here on the picture on the right side, they have a camera on top. And with that, all of a sudden you have a very different colleague in there. in order to do something meaningful in the manufacturing side. And what you can do there, you see here, this is Spot now in an operator environment, and he's running around the manufacturing side, and his task is to check the status quo of the fire extinguishers. So you see on the on the top left side the path he's choosing. He goes then to the fire extinguisher position and check whether the fire extinguisher is there, okay, accessible whatsoever. As an example in terms of what the potential use case is. So Spot goes further through the facility and again looks for the further spots for fire extinguishers. And there, oops, there is none. So there's a problem. There's a fire extinguisher missing. So this Spot now orders directly within the system a replacement. So there's a Maximo order management system behind that, and Spot directly triggers the replacement of that particular fire extinguisher. So it's quite an interesting connection also to the back end of the environment. So next one, there is a fire extinguisher, but it is not accessible. That's of course a no-no. So again, Maximo work order, there's a block obstacle, somebody needs to fix that. Spot cannot put away that. That would be the ideal thing. But you see, and you get the feeling how this is used. And again, this technology has been used in big nuclear plants, for example, with hazardous environment for people. The German police is using this to check fire situations here in private lives, for example. So there are a lot of different use cases around that in this kind of technology. So all this looks nice and fine, but we also wanted to give you a little bit insight in terms of how this really works on the technology perspective. And there I'd like to pass over the word to Dilek. Dilek, over to you.
Yeah, thank you, Torsten. So you have heard this already from Torsten. He told about that you could hear or that you could see something. Base of everything within IBM are a kind of software which you could use for AI, what makes your life a little bit better. Yeah, so you could program everything in PyTorch, you could program everything with open source tools. But we in IBM gave the support that you are getting any kind of software which is helping you to do the same kind of things, but in a faster time or without any big programming approaches. And one of the softwares are Maximo Application Suite. You have heard this already about Spot. And he has this kind of visual inspection in his area into it. Maybe we have the chance to look at a demo. Yeah, I need to have a look whether this will work. But meanwhile, we will go through this. What is Maximo Visual Inspection? So you have the possibility to train data. First of all, you need to train that data in any kind of server or also in SaaS or in cloud. But this software, you need to know this software is not on cloud. You need to buy it, but you could use it in cloud, of course, and you could use it also on-premise. You are programming this kind of software, and then you are taking it to a mobile device. So you could take it in any kind of mobile device to have it portable and to could use it. And in Spot, you have seen this already there. This is a kind of mobile device which you could use. And of course, you need then the edge where you could easily configure the things and inspect all the models you are having here in that case. Yeah. So this is when we are talking about Maximo Visual Inspection, or when we are talking about visual inspection, then this is our Maximo suite, which you could use also then with other additional things. Maybe one point to visual inspection in manufacturing, you do not have these cases, but we as IBM are not recognizing faces. Yeah, from the trustworthiness, this is one point where we said we will not do this. And in the plant area, you usually do not have this. You are looking on the plant, whether this is working. You are using it for predictive analysis. You are using this, whether the kind of product you are getting is missing something or something like the Spot, what you have seen before. Here you are seeing some kind of screenshots also from that, what you could do with visual inspection. The first thing, of course, is you have data sets. So you have a lot of pictures. For example, you are saying, I'm in a plant and I want to know cheese, yeah, or I want to get the best cheese in the plant, for example. Then, of course, you need a lot of pictures of cheeses and how it has to look like and how it's not looking like. And then you are labeling this object and the videos maybe you are having and all the things you are having, yeah. And you use then this kind of software to train afterwards the labeled data and of course to deploy it. And you could deploy it then on the mobile or also on the edge phone. This is all what is behind it. It's very, very simple to use it, even if you are not familiar with training or labeling data. So when we are looking further into the next chart, then you could see which kind of images you also could use, because images are not the same and sometimes they are different. So you could do with Maximo Visual Inspection, image augmentation, classification, object detection, and image segmentation. So you have a lot of different possibilities which you could use here. Yeah, and I see now in the chat, can we label be done with object recognition models as well as manually? That would be cool. Yes, you could. And if it's later working, I changed, maybe you have seen it, I have changed my screen. So I hope that I could maybe show now the demo, and if it's work, you could see how it's really working live. Yeah. Okay. And that will be now the point to change. And maybe now it's really working.
Maybe just one comment on the question also from my side. When while Dilek is trying to make the technology work, yes, there's a manual way of doing this, and actually in India there are thousands of people doing manual tagging on street pictures, for example. So the entire environment in terms of self-driving cars, that's a huge environment in terms of tagging and evaluating pictures that cars have been taken. So there is a semi-automated process doing that, but there's still a lot of manual work to tag pictures and really train the system, teach the system what is good, what is bad. So that's a very typical thing in the self-driving car environment, for example.
Yeah, so yeah, I just tried it. It had not worked. Yeah, it's really
okay.
It's really simple. Yeah, if you are going to the tool, it's really showing you all what we have in Watson in Maximo. You could go then to visual inspection. And then when you are saying, I'm now in visual inspection, you are taking pictures. Yeah, you could load any kind of pictures you are having into the systems and then just press a button. And with this button, you are getting already a trained system. So everything the tool is doing in the background. So it's very simple. And you see here, you have a kind of management, a kind of monitoring, a kind of health and digital twins you could do in the software also, and also a kind of prediction. And visual inspection is only one of these applications in this Maximo suite. So you have a lot of possibilities who are all around the manufacturing area. Yeah. So you could use everything of this in this one tool. Could label your data, you could train your data, you get then a kind of accuracy out of it, and you have them all in it, yeah. So if you wish, yeah, Thorsten, this would be good.
Sorry,
yeah,
to driving to, yeah. We need to push a little bit on timing, Dilek. Sorry, that's the reason why
okay.
I'm a little bit irritated here.
Okay, cool. Then let's go to the sustainability subject. So we had the talk about Maximo, and that this is an AI software, and that AI is really great to use in the manufacturing area. Thorsten had said this also already. And the other thing is in the sustainability area. So that what we are seeing in the moment is that a lot of companies are working on sustainability to get this done. But for sustainability, also AI, you could use AI to get this done, yeah? And here are some major drivers for the point that you could use or to case, take the sustainability subject. Yeah. And of course, a lot of companies are looking at the funding. So this is funding driven, that they are saying I could get sustainable projects and could get innovations out of this and could get a lot of more money with that from programs out of fundings, because some governments are financing it when you are going into the sustainability area. There are compliance regulatory. And here in Germany, you have, for example, Lieferkettengesetz. So you need to show as a company end to end from where this product is coming, and that there is no child is working on it, for example. Then you have a changing customer demand, of course. Yeah. So a lot of young people who are coming are really looking at this, and you know this from Friday for Future, for example, that there are a lot of things that they are using it. Yeah. So there are a lot of drivers in that. And for example, the companies are needing to transform now. And we have categorized them a little bit. You have business models and a transformation in it. So we are working on that area, also on the value chain optimization and in the sustainable data management. So if you wish, we are clustering in these 3 areas, the sustainability subject. And with that, we are trying to focus with AI, but also to get sustainability in the companies. So, Thorsten, I think that's it from my side. I think we are now on the end.
Yes, we are kind of at the end and okay on time. But by the way, we have one more thing for you. And it's now time again to go to the chat window for you guys. And we have another probing exam question. And I'm being very eager to understand what you think the answer is. So the question is very simple. If you look on the picture on the right-hand side, what is this? Go to your chat window and give me your best guess. What do you think we see here?
Already quantum computing.
Oh, the first one crashed already the question. Yes, Krishant, you're damn right. This is the inside of a quantum computer. And you might wonder why the hell quantum computer? And usually I have then the question to the audience, okay, you know what that is. And then the second question is, who feels comfortable to explain what a quantum computer is or does? And then usually most hands go down. So I don't raise the question for you in terms of how a quantum computer works, and it's probably not the expectation that I can answer that within a minute or so. However, let me give it a try. So if you just take a regular coin, right? So all we have done in terms of computing in the last 100+ years, it was about digital. It was about a 0, head or tails as a 1. And this is the basis of everything what we have done so far in terms of computing. Of course, we improved computing power, time, cost, blah, 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 blah. But it was all still the binary digital 0 and 1 in order to run all the systems we are using these days in terms of banks, in terms of airline booking, and so on and so forth. However, in a quantum computer, you don't have only the 1 and the 0, but you also have anything in between. So you have so-called quantum bits. And that allows you to a much bigger power of a quantum computer overall. So there are still a lot of problems out there where a regular computer doesn't help to the extent. Operations research, traveling salesmen, manufacturing, network optimization, encryption security is a big topic. So the last Z series, for example, our flagship product we just launched a couple of weeks back, this is quantum ready or protects against quantum attacks. So one of the bad things of using this potential technology is, of course, using quantum computer to attack security networks. So more and more is happening in this side. So quantum is the next big thing in terms of computing. And there's a lot of stuff that we offer also for universities in order to do that. The question, though, is how to use quantum in manufacturing. So what are the typical use cases here? And I put a couple together here in terms of where do we see the value of quantum computing. And again, these are all typical problems where regular computers already work on today, but quantum would give them a major, major improvement. And I'm not talking about making things 2 times faster or 3 times faster. I'm talking about 10,000 times faster. And there are a couple of problems there where computers today cannot give an answer. Well, you need to have quantum computer to do that. So production scheduling is a big topic there. Again, network optimization, supply chain is a typical one, and so on and so forth. And you see the typical business values, which this drives: revenues, efficiency, speed, better quality. So all these kind of nice things where you usually have regular computer giving that just a little extra step to improve there. But we expect a major, major leapfrog on this technology and these kind of processes once this has been deployed. That might all sound little theory, but I also brought with you for you right now one exact case study. And you can read much more on this case study on the link you see on the top. So this is a project that we do here in Germany with Mercedes-Benz. And one of the deployment use cases that they are working on is energy efficiency of batteries. One of the biggest challenges right now in terms of our switch to electric vehicles is, of course, range. We have all we have all seen the activities that's 600, 700 kilometers. This is kind of the current range that you can see with classical batteries. But if you really deploy quantum capabilities to battery research, there's the expectation there's a fundamental step forward in terms of efficiency using batteries. So this is a project which is more like on the chemistry research side, if you like, so to find a better way to have better efficiencies of batteries. And there's one of the big use cases here, and again, much more, including a video on the case study here. So, so this was the journey from AI to sustainability to quantum, and that really brings us to the end.